Hello, I'm CJ Boyce, a research scientist in the Frenkel Laboratory at Seattle Children's Research Institute, and today I'll be presenting the results of a multi-cohort study our group conducted, investigating the frequency of dolutegravir resistance by co-administered nucleoside reverse transcriptase inhibitors, or NRTIs. Globally, most antiretroviral therapy combines the second-generation integrase inhibitor dolutegravir with tenofovir and lamivudine. However, dolutegravir in combination with other NRTIs can be prescribed for second-line ART or in pediatric populations. The Nadia and Odyssey B studies both found a greater frequency of dolutegravir resistance among participants who received dolutegravir with zidovudine, though due to small sample sizes, neither result was statistically significant. These data raise the question, does the frequency of HIV resistance to dolutegravir vary depending on the co-administered NRTI? Due to dolutegravir's long dissociative half-life from the wild-type integrase enzyme, we hypothesized that co-administration of NRTI with relatively shorter intracellular half-lives, such as zidovudine or abacavir, would be associated with increased risk of dolutegravir resistance compared to NRTI with longer half-lives, like tenofovir. To test this hypothesis, we conducted a nested multi-cohort observational study that included participants from 4 different parent studies. P1093, a phase 1-2 pharmacokinetics and safety trial of dolutegravir with optimized background therapy in integrase inhibitor naive, mostly ART-experienced children in Africa, Asia, and the Americas. Up4Kids, a randomized trial of point-of-care viral load testing plus genotyping versus standard of care in children in Kenya. SHARP, a prospective cohort study that used assisted partner services to identify, test, and link to care people who injected drugs living with HIV in Kenya and their partners. And Pretoria Immunology and Virology Studies, or PIV, an ongoing cohort study of individuals prescribed dolutegravir ART in Pretoria, South Africa. Our nested study included all 181 participants from P1093. 135 participants from the Up4Kids main study and an extension study who were prescribed dolutegravir-based ART. 250 former SHARP participants who had been prescribed dolutegravir for at least 6 months and were enrolled in a prospective cohort study called DREAM Kenya, and 94 PIV participants who were prospectively observed in a study called DREAM Pretoria. Of the 660 participants in our nested study, 235 experienced at least one viremia, defined as HIV RNA greater than or equal to 200 copies per mil. Genotyping was performed on plasma HIV from these participants using the PacBio sequencing platform with unique molecular identifiers to allow for quantification of HIV copies sequenced and the detection of drug-resistant minority variants. Sanger sequencing was performed if plasma HIV was limited by volume or viral load. The participant outcomes were categorized as dolutegravir resistance scores less than 30 or greater than or equal to 30 using the Stanford HIV database algorithm. To summarize our main findings, dolutegravir resistance mutation scores greater than or equal to 30 were detected in 21 out of the 183 participants with viremia, with mutations G118R detected in 9 participants, Q148H or K detected in 3 participants, and R263K detected in 10 participants. Univariate analyses found that dolutegravir resistance was associated with younger age, subtype B HIV, enrollment in P1093 or DREAM Pretoria, having a viremia between 1,000 or 10,000 copies per mil, and the co-administration of abacavir or zidovudine, which included 1 onstavudine in this group, compared to tenofovir. The heterogeneity, for example, participants' age, duration of study follow-up, number of viral load tests, and the NRTI prescribed, was observed across our cohorts, which likely led to the associations of dolutegravir resistance with cohort and age in our univariate analysis, due to the relatively high frequencies of zidovudine prescriptions in both DREAM Pretoria and P1093. In the multivariable stepwise logistic model, the increased frequency of dolutegravir resistance was retained for both abacavir and zidovudine, with adjusted odds ratios of 5.4 and 19.4 respectively, compared to tenofovir. In conclusion, the co-administration of tenofovir with dolutegravir plus lamivudine appears to reduce the risk of selecting dolutegravir resistance compared to co-administration with zidovudine or abacavir. We postulate that the selection of dolutegravir resistance is potentiated by NRTIs with relatively shorter intracellular half-lives during lapses in ART adherence due to periods of functional dolutegravir monotherapy when dolutegravir is not supported by the co-administered NRTIs. In closing, I would like to acknowledge all of our study participants, study teams, and collaborators, as well as our funding. Thank you.